Okay. Assalamualaikum warahmatullahi wabarakatuh. So this is the lecture video for week 3 of STA 104. Okay, in this video we will learn about the describing data. Okay, this is the beginning of chapter 2. As we learned before, there are two types of variable or two types of data. Okay, the first one is qualitative and quantitative. And to organize and graphing qualitative and quantitative data, we use different presentation. Okay, for organizing and graphing qualitative data, we will use either frequency distribution or frequency table, pie chart, bar chart, and contingency table. So we will learn this one by one. Okay, the first one is for frequency distribution, or we can also call it as frequency table. We use it to present the qualitative data. Okay, so in frequency distribution, it is the form of table, okay, consisting of several columns and rows. A column may consist of categories of data. Okay, a column is for the categories, and a class is a category into which qualitative data can be classified. Okay, class frequency is the number of observation that fall in a particular class. For example, a car dealer in KL, Kuala Lumpur, makes the sales for several types of cars in the month of January 2022. Okay, as shown in this table. The first column consists of the qualitative variable. Okay, that is the car models. While the second column is the frequency of the types of the car sold. Okay, the variable consists of 6 models of cars, namely Proton Saga, Proton Persona, Proton Azora, Proton Iris, Proton X70, Proton X50. This type of table is usually called frequency table or the frequency distribution for qualitative data. Okay, frequency distribution summarizes data into different classes and their frequency. In a pie chart, okay, this pie chart can be used to represent categorical data. It consists of one or more circles that are divided into sectors. Okay, the sectors shows the percentage or the proportion of the number of objects in each group of or category. Okay, the angle of the sector, okay, angle, each of the sector has angles here. The angle in the sector is proportional to the number of percentage of the element in that category. So when you are constructing a pie chart, you have to calculate the angle of the sector. Okay, angle of each sector first. For example, okay, the table below provides information on the total export in million tons of Malaysian rubber based on grade for year 1989. So based on this table, you need to construct a pie chart, okay, to represent this information. Okay, so before we construct our pie chart, you need to know how many categories are inside this question. So in this question, the number of categories is 3, which is SMR, 4, okay, which is SMR, RSS, latex, and other grades. So we have 4 categories here. And then we need to find the percentage of each of the categories. Okay, the first one is for SMR. Okay, 907.07 divide by the total export, which is 1487, okay, times with 100. Okay, put out your calculator. So it is equal to 61%. Okay, and then for RSS, 267.66 divide by 1487 times with 100%. So it is equal to 18%. And for latex, 237.92 divide by 1487 and then times with 100%. Okay, equals 16%. And then for others, 74.35. Okay, so we calculate it. 74.35. Okay, so it is equals to 5%. And then this percentage should be converted to degrees. Okay, degree of total of 360 degrees before we draw our pie chart. So how is being calculated? Okay, so to calculate degree of each of the rubber grade, so for SMR we have 61%. Okay, so 61% times with 360 degree. So in your calculator, you need to write 61, okay, divide by 100 and then times with 360. Okay, 61 divide by 100 and multiply 360. So it is equals to 219.6 degrees. For RSS, 18% times with 360. So just use your calculator. So it is equals to 64.8 degrees. And then for latex, okay, latex, 16% times with 360. So it is equals to 57.6 degrees. And for others, 5% multiply with 360 degrees. Okay, so it is equals to 18 degrees. Sorry, it is not percent, this is degree. Okay, so you draw round shape, okay, and you need to estimate the degrees of each of the sectors. Okay, 219.6, 64.8, 57.9 and 18 degrees. Maybe you can use your protector. Okay, so dia lebih kurang macam ni lah. This is for SMR, 219.6. Sorry, 61%. And then for this one is for RSS, 18%, latex 16%, and others 5%. Okay, so your pie chart should be like this. Okay, next one is the bar chart. A bar chart is another graphical method for describing data that can be divided into categories. It is frequently used in newspapers, magazines, and companies' annual reports and other presentations to convey and highlight the information. A bar chart uses the length of horizontal bar, okay, if it is a horizontal bar chart, and vertical column if it is vertical bar chart to represent quantities or percentage. Okay, there are several common types of bar chart. They are vertical bar chart, horizontal bar chart, cluster bar chart or the multiple bar chart, and stack bar chart. In vertical bar chart, okay, this is the vertical bar chart. In vertical bar chart, we have vertical columns, while in horizontal bar chart, we have horizontal columns. In cluster bar chart, it uses several bars of each item, while in stack bar chart, it is the chart is stacked up and down or left to right. Okay. Okay, for example, this table represents the number of estimate demand for engineers and assistant engineers for the year of 2000. Okay, so we need to present the above data using a multiple bar chart. So our multiple bar chart should be like this. Okay, first one, we need to label the vertical axis, okay, or the y-axis with the number of object. So here is our vertical axis. Okay, vertical axis is for the number, okay, number of object lah. Okay, so if we look here, our number of engineers and assistant engineers is thousands. So maybe our vertical axis can be labeled with starting from 0 and then until, and the most number is 190,300. So in our vertical axis, maybe we can construct it like this. This is the number of engineers, number of people, okay, number of people in thousands, so that we don't need to write large numbers. So if we put thousands here, so our numbers will be like just 2 digits, okay, just 1 and 2 digits numbers. Okay, maybe our vertical axis can be like this. Okay, we have number of people in 1,000, so our numbers are from 10 until 190. So 10 means 10, 20 means 10 means 20,000, 10 means 10,000, 20 means 20,000s, and the largest number is 190 means 190,000s. Okay, and then we need also to label the categories along the horizontal axis. So our horizontal axis is in the category of mechanical, chemical, electrical. Okay, so it is like this. Okay, and then Next step is we need to construct a rectangle. Okay, rectangle or the bar over each category with the height of the rectangle equal to the number of people in that category. So the base of each rectangle should be of the same width. So here, for the category of mechanical, the number of engineers is 10,800. So it is here. Kat sini kita pilih color lain. Okay, contohnya red I choose for the number of engineers. So it is here 10,800. So kat sini lah, lebih kurang sini. Please draw your chart with your ruler. Okay, so it will become nicer. Okay, this is the number of engineer, which is 10,800, and then the number of engineers in chemical is 2,000. So 2,000 is dekat sini je. Okay. Then for electrical, 14,600. So 14 is right here. 14 lebih kurang sini 14. Okay, it is slightly short. It is slightly sorry, untuk mechanical tadi salah. Okay, untuk mechanical tadi dia mesti rendah sikit. Okay, untuk mechanical lebih kurang sini. For chemical, it is on only 2,000. So for electrical is 14,000. It is slightly taller than the mechanical. And then for civil is 19. Okay, 19, it is slightly taller than the electrical, but not exceed 20. Okay, and then for others is, oh sorry, our vertical axis shouldn't be as long as 190,000, because 190,000 is the total. Okay, the total. So our vertical axis should be as many as the paling besar is 70,000. So it should be until here only. Okay, I will draw another chart. Okay, I'm sorry. Our bar chart should be like this. This is the actual bar chart. So for mechanical, I will use for the number of engineers, I will use the red color. So the number of engineers for mechanical is 10,000. Okay, 10,800. So it should be right here. Okay. Okay, for chemical is 2,000. So it is shorter than the bar for mechanical. And then for electrical, 14,600. So 14 is taller, slightly taller than the mechanical's bar. Okay. And then for civil pun dia panjang sikit je daripada electrical. And then for others is 9,700. Okay, lebih kurang kat sini. Okay, And then I will use a green color for the number of assistant engineers. Okay, in mechanical, the number of assistant engineers is 32,000. Okay, 32 is right here, 32. Okay, and then for chemical is 6,000. 6,000. Okay, so electrical 70,900. For civil is 58,500. And for others is 22,500. Okay, so our cluster bar chart or the multiple bar chart should be like this. Okay, for this question. Okay, let's proceed to the next slide. Okay, the contingency table. Okay, a contingency table is also known as cross classification table. Okay, it is often desirable to examine the categorical response in terms of two qualitative variables simultaneously. So, it is suitable for data which has two qualitative variable. Okay, like this. Okay, in this table we have two qualitative data, which is the gender and the sport. Okay, type of sport. For contingency that has two variables, we call it as two-way table, and for contingency table that has three variables, we call it as three-way table. So this table is the example of table that has two variable, and we call it as two-way table. Data from this table can be grouped according to two criteria of classification. Okay, and then we proceed with the organizing and graphing quantitative data. We can organize and graphing quantitative data in terms of stem and leaf plot, frequency distribution of group data, frequency distribution of ungrouped data, histogram, frequency polygon, and cumulative frequency distribution and OGIF. For the first one is the stem and leaf plot. It is used when the data set is small. In a stem and leaf plot, each data value is split into a stem and a leaf. Okay, the leaf is usually the last digit of the number, and the other digits to the left of the leaf form the stem. Okay, noted that only one digit after the stem can be used as leaf. So this is the steps in constructing a stem and leaf plot. Okay, the first step is you need to write the data in numerical order. Okay, but it is not a required step. Okay, the second step is you need to separate each number into a stem and a leaf, and then group the numbers with the same stem. Okay, you need to list the stems in numerical order. Okay, and give the title of the graph. And then the last step is prepare an appropriate legend key for the graph. Okay, for example, we need to display the following data with a stem and leaf plot. Okay, here our data is 81, 61, 77, 71 until 86. First, we need to arrange the data in order form. Okay, so the order is we begin with 61. Okay, begin with 61, and then 71, Okay, this is the data that I have arranged. We begin with the smallest number, which is 56, and the largest is 133. So you can see here, the number 81 occurs 3 times, and number 86 occurs 2 times. So the data in ordered form is like this, and then we need to plot it in the stem and leaf. So for this data, the stem and leaf plot is as follows. Okay, this is the column for stem and for leaf. Okay, so the list of stem is the first set of digit. Okay, the first digit. So kita tengok the first digit is 5. So we write 5, 6, 6, 6, so 6, 7, okay, 7, 7, 8, 9. Okay, and then 11 and 13. So this is the list of our stem. Okay, so what will be our leaf? Okay, here in our data, 5 is paired with 6. So we should write 6 here. Okay, it means that 56. Okay, and then we have 61, so 6, 1. And then we have 66, so 6, 6. And we have 69, so 6 and 9. Okay, and then for digit 7, we have 7 paired with 1, 71. And then 77. Okay, and then for digit 8, okay, we have 81, 81 and 81. So 81, 81, 81. Okay, then for 9, okay, 9, it is only 91. Okay, 91 here. Okay, and then for 11 paired with 1, okay, 111 and 111. And then the last one is 133. Okay, it means that 13 paired with 3. Okay, this is the form of our stem and leaf plot. Okay, for the next one is the frequency distribution of an ungrouped data. Okay, frequency distribution for ungrouped data. Okay, this is the example of ungrouped data. Okay, our data in the form of list. Frequency distribution is a summary table where the data are grouped into a number of class. Okay, the objective is to obtain the number of responses associated with the different values of the variable. So for example, consider the following set of data. We can see here, for example, the value of 112 occurs 1, 2, 3, 4 times. Okay? The value of 112 occurs 4 times. Therefore, the frequency, its frequency is 3. Okay, and then other example is the number of 110. Okay, here we have here 110, 110 once, and then 2 times, 3 times, and 4th time. So the frequency for number 110 is also 4 because it occurs 4 times. Okay, so our frequency distribution should be like this. Okay, our first column is for x, where x is the values of our or the numbers in our data, and the second column is for the frequency. Okay, frequency, we noted it as f. So our x is we have the list number is 100. So we have 100 that occurs only one times in that data, and then 104 occurs how many times? One. I guess it is only once. And then 105 occurs how many times in this data? 1, 2, 3. Okay, 3. So its frequency is 3, and so on until the largest data is, I think it is 184. Okay, so itu cara nak construct frequency distribution of an ungrouped data. Okay, the next one is frequency distribution of a group data. So these are steps in constructing a frequency table for group data. First step is you need to decide on the number of classes, and then determine the class interval, and then set this class interval, and the last one is tally and count the number of items in each class. Okay, for example, this is the data for number of books borrowed by students in the library each day for the month of January 2004. Okay, this is our data. And the first step is we need to decide the number of classes. Okay, so to decide the number of class, we have a formula which is 2 power of k, okay, larger than n. Okay, 2 kuasa k besar daripada n, where n is the number of observation. So based on the previous slide, okay, kita punya soalan tadi, tengok balik. Okay, so here we have the data of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here we have 31 datas. So to calculate to decide the number of classes, we have this formula 2 power of k more than n. So our n here is 31. Okay, so how to solve k? We need to put log each left side and right side, or ln ln 2 power of k ln 31. So k, bring it in front, so k ln 2 ln 31. So k is ln 31 divided by ln 2. So just use your calculator. Ln 31 divided by ln 2 is 4.9541. Okay, 4.9542 lah. So k, our k is more than 4.9542. So we can decide we want to use the value of k is equal to 5. Okay, k is equal to 5. So, and then this is first step. Okay, we need to decide the value of k. And then for the second step, we need to determine the class interval. Okay, for this one, we also have a formula for that. Okay, the formula is I more than or equals to h minus l divided by k. Okay, where I is the class interval that we want to search for, h is the highest observed value, l is the lowest observed value, and k is the number of class. Here our k is 5. So just substitute all the values of the variables here. So we have our h is, okay, the highest observed value that we found in our previous data is 60, and the lowest value is, I think it is 21. Okay, that's right, it is 21. And then divide with our value of k, which is 5. So I is larger than or equal to 8.5.